Hello and welcome to the another tutorial of this Blockzie module. Here we make your coding journey easy and fun. So in the previous session or previous tutorial we have seen how one can connect a simple LED or a few more LEDs and try that coding in Blockzie. So in the previous session we have connected LED and push button with Arduino Uno and did the coding in Blockzie. Similarly, we have connected 7 segment with Arduino Uno and done the coding for the same in Blockzie. Now moving forward with sensors and actuators. So whenever you are adding sensors or actuators in your project with the microcontroller, then how you can interface that sensors and actuators with Blockzie. So in order to interface the sensors with Blockzie, this is the particular and dedicated tutorial to do so. So in this tutorial we are going to learn about the introduction to sensors and actuators, and after that we will see the interfacing of sensors with Blockzie. So the table of content for this particular tutorial is divided in three parts. In the first and the introduction part, we are going to see the basics about sensors and actuators. That what are sensors and the actuators. In the second part, we are going to see the interface of ultrasonic sensor with Arduino Uno. That one of the many sensors is our ultrasonic sensors, and we will see the interfacing of that sensor with Arduino. In the third and the last part of this session, we are going to see the interfacing of IR sensor with Arduino Uno. That how one can connect IR sensor with Arduino Uno and do the block coding in Blockzie. So these are the three parts of this tutorial. Let us start with our first part of this tutorial, and that part is what are sensors and actuators. So let me introduce you with the sensors and actuators. First we will see what are sensors. So as we know that from its very basic name or the naming definition, the sensor is something which can sense. So the sensors are device which can sense a particular thing around their environment. So as we know, sensors sense just like eyes and ears do. The sensors detect the change in the environment. It can be temperature sensor, pressure sensor, or humidity sensor. So whatever change there is in environment is going to be sensed by a particular sensors. So sensors are made for different kinds of sensing elements. In order to sense temperature in the surrounding environment, you can use temperature sensors. So the measured information or the data being sensed shall be sent to the processor or the controller for them to work on it or to process it. Once the sensor senses the environment or the surrounding medium, it gives the data or it sent this measured information to the processor or controller, which going to control the devices next to them, and that will process onto it. So the sensor is a device which is used for the conversion of physical events or the characteristics into the electrical signal. So the sensors do one thing, and that one thing is it takes the data which is the physical events from its surrounding medium or the other characteristics, and their main function is to transform or converts that physical event into electrical signal. This is a hardware device that takes the input from environment and gives to the system by converting it into electrical signal. For example, a thermometer. So a thermometer takes a temperature as a physical characteristic and then convert it to electrical signals for the system. So the system next connected to it will use this data which has gained as an electrical signal, and then they will perform the next thing. So this is the block diagram of a sensor. So this is a sensor. This is the environment, or you can say the physical quantity which is which is in the surrounding medium of sensor. So that physical quantity will be taken by sensor that senses and it will convert it into electrical output. So this is how a sensor works. These are the different types of sensors which are there in the market or we use on daily basis in some of the events. So for example, a potentiometer, flex sensor, force sensitive resistor sensor, LDR sensor, air or water level sensor, soil moisture sensor, rainwater sensor, MQ2 gas sensor, temperature and humidity sensor, microphone sensor, ultrasonic sensor, IR sensor, PIR motion sensor, Plull sensor, Hall effect sensor, joystick module, and capacitive touch sensor. So these are the different examples of sensors which are there to sense a particular quantity. For example, the ultrasonic sensor, it is going to be used to measure the distance. Thereafter is actuators. So what are the actuators? So from the name of this device we can see that this is something which is going to take action, right? The actuator. So the actuator are devices that are used to produce action or motion. In oppose or in the contradiction of sensor, the actuator will give or produce some action or motion. So actuator is a device that converts the electrical signal into physical events, or you can say in characteristics. So it takes input from the system and give output to environment, opposite to the sensors. Sensors takes the physical quantity and gives or converts it into electrical signal, whereas your actuator is a device which first takes input from system and then it gives output to the environment. So it has first electrical signal and then it is the device that convert that electrical signal into a physical event. For example, motors and heaters. So these are the commonly used actuators. So motors does what they does, they takes electrical input and in return they are going to be there to rotate something or to make a motion. So this is the block diagram of actuator. So this is the actuator. They will have some control signal from controller and they are going to perform the action or motion in environmental change or by changing the physical quantities. So these are some of the examples of types of actuators. There are so many types of actuators and these are the sum of the example. For example, BO motor, DC gear motor, stepper motor, servo motor, vibration motors or water pump modules. So these are some of the examples of the actuators. So let us see now the difference between sensors and actuators. As we discussed what are sensors and what are actuators, we know that the sensors, they are something that converts the physical characteristics into electrical signals, whereas the actuators converts the electrical signal into physical characteristics. So they are opposite to each other. The sensor takes input from environment to perform the next function, whereas the actuator takes input from output conditioning unit of the system. Now the sensor gives output to elect input conditioning unit system, whereas the actuator gives output directly to the environment. Sensor generates electrical signal, whereas actuator generates heat or motion. First, actuator takes some electrical signals and in return they generates heat or motion. For example, the motors. We connect it to the supply and then they do the rotating or they do the motion function. The sensors are placed at output port of system, whereas the actuators are there at the output port. The sensors are used to measure the physical quantities, whereas the actuators are used to measure the continuous and discrete process of a parameter. Now, sensor gives information to the system about the environment, whereas the actuators accept command to perform a specific function. So the example of the sensor is, you can see, as a photovoltaic cell which converts the light energy into electrical energy. Whereas the actuator's example is stepper motor, where electrical energy drives the motor. So as soon as you connect the stepper motor to supply, it will drive the motor. And in return, it will rotate some or other part of a system or machine. So now here is our second part of interfacing of ultrasonic sensor with Arduino Uno. As we discussed in the previous sessions, that Arduino Uno is a microcontroller and using which you can control so many devices on same time as well. So here we are going to connect the ultrasonic sensor with Arduino Uno. So Arduino Uno here is a microcontroller and ultrasonic is a sensor. So first of all, let us discuss that what is ultrasonic sensor. So the ultrasonic sensing is one of the best ways to sense, you can say, proximity or detect levels with higher reliability. So an ultrasonic sensor is the instrument that measures the distance to an object using the ultrasonic sound waves. As the name has, ultrasonic means it uses the ultrasonic sound waves. So it is an electronic device that measures the distance of a target object by emitting ultrasonic sound waves and converts the reflected sound wave into an electrical signal. So an ultrasonic sensor uses a transducer to send and receive ultrasonic pulses that relay back information about an object's proximity, or you can say sometime distance. So these ultrasonic waves travel faster than the speed of audible sound. Now the audible sound generally, or the human audible range, is from 20 hertz to 20 kilohertz, whereas the ultrasonic are the waves which has the frequency more than 20 kilohertz, right? So this sensor works on that ultrasonic waves, and that ultrasonic waves are used to transmit. So first, the one module here, you can see from its diagram also, or the module, that it has two different modules. The first is transmitter and the another is receiver. So transmitter will transmit the ultrasonic wave or sound, and this will receive. So once it will emit the ultrasonic waves, if there is object, or you can say obstacle in between, then it will reverse or it will be reflected. The sound which is emitted will be reflected if there is any obstacle, and that reflected sound will be received by this module. So the high frequency sound waves reflect across boundaries to protect distinct auto echo patterns. Now we will briefly going to see that how does it works. So ultrasonic sensor works by sending out a sound wave at a frequency which is generally above the range of human hearing. The transducer on the sensor acts as a microphone to receive and send, which this is the transducer, and it acts as a microphone to receive and send the ultrasonic sound. Now, this ultrasonic sensor uses a single transducer to send a pulse and to receive the echo. Now, here this transmitter will transmit ultrasonic sound, and after that, if there is any obstacle in between, then the transmitted wave will be reflected after collision with the object. Now this reflected wave is going to be received by the receiver module, and the sensor determines the distance to a target by measuring time lapse between the sending and receiving of this ultrasonic pulse. Means the time taken by the module by emitting between the emitting and receiving. So the working principle is simple. It sends first the ultrasonic pulse which travels through the air, and if there is an obstacle it will bounce back to the sensor, and by calculating the travel time and we know the speed of sound, the distance can be calculated. So this is how the ultrasonic sensor works. And the usual range of this sensor, or you can say the detection range, is from 2 centimeter to 400 centimeters. Now let us see the module first. Its resolution is 0.3 centimeter, whereas the angle is the 15 degrees of angles. Here the module, or you can say the ultrasonic sensor module, has 4 pins, namely first VCC pin, second trigger pin, third echo pin, and fourth ground pin. Wherever we are going to add this particular sensor with Arduino Uno, we need to connect this pin in order to get the data. So these are the applications of ultrasonic sensor. So ultrasonic sensor can be used in anti-collision detection, people detection, countering and profiling, presence detection, box sorting using a multi transducer system, easy control of trash collection vehicle, pallet detection, bottle counting on drinking filling machine, automatic doors or automatic hand washers, industrial and distribution robots, and trash level monitoring. So these are some of the example of this application of ultrasonic sensor. Now it's time for us to interface the ultrasonic sensor with Arduino Uno. So we are going to connect the Arduino Uno and ultrasonic sensor. So here we are going to make a distance measuring device using the ultrasonic sensor and Arduino, which can measure the distance from range 2 centimeter to 400 centimeter. So this is the simplest task when we want to see how the ultrasonic sensor works. So whenever there will be an object, the sensor measures the distance between the sensor and the object, and then it will be printed on the serial monitor window of Blockzie software. So here we are going to use Blockzie software for coding. So the hardware required to build the circuit is Arduino Uno board, USB A to B type cable, computer or laptop, few jumper wires, and one ultrasonic sensor. And the software required is Blockzie. So this is the circuit diagram for ultrasonic sensor connection with Arduino Uno. Here the ultrasonic sensors pins, and they are going to be connected with Arduino Uno's pin. Here VCC pin is connected to the 5 volt of the Arduino Uno's 5 volt pin. GND pin of the ultrasonic sensor is connected onto the GND pin of the Arduino Uno board. After that is time to connect the trigger pin and the echo pin. Now trigger pin here is connected onto the pin number 3, or you can say the digital pin number 3 of Arduino Uno board, and echo pin of the ultrasonic sensor is connected to the digital pin number 2 of Arduino Uno board. Here we have connected the LED to see the result. Hence the LED is connected onto the pin number 13. So the LED's anode terminal is connected onto the pin number 13, and the GND pin of our Arduino Uno board is connected to the LED's cathode terminal. Now in order to add the ultrasonic sensor, first we need to open the Blockzie software, and in the bottom leftmost corner of the Blockzie interface you will have an extension option under the block programming's different 9 blocks category. So click onto this icon, which is an add extension option, and then choose an extension as ultrasonic. Now when you click on this icon, you have one particular screen like this. Here are the different sensors from which you can select one. So here we are using ultrasonic sensors, and click on to ultrasonic, and you will have the blocks related to the ultrasonic sensors in the block programming palette. Now after adding the ultrasonic sensor and connecting the Arduino Uno board, it's time to do the coding. So for coding, we are going to require to add few blocks in order to do the coding. So for that, first we need to add Arduino Uno board. So click on to node device selected and select Arduino Uno board, and you will have the pins option for this Arduino Uno board. From from the very uppermost corner of right side, switch the mode to the upload mode, and from event category choose the when Arduino Uno begin option or block. Drag and drop into coding area, and after that click on to pins category and select drag and drop the set pin mode type block, and we are going to connect this after when Arduino Uno begin. So here we have connected the LED onto pin number 13, and select the 13 number pin and the mode of it as output mode. So here we have connected the LED onto pin number 13 or digital pin number 13 of Arduino Uno as output device. Now whenever there is something, or whenever there is a particular object at a particular distance, then we want the LED to turn on in order to see the detection, or in order to indicate the presence or the obstacle coming in front of the sensor. So this is what we are going to build. We want to build a circuit which senses a particular distance, and if at particular distance there is some obstacle or object, there should be an indication. So for indication we are using the LED, hence it is output. And whenever there is something at a particular distance, your LED should turn on. If there is nothing in between or in that range, then your LED should be in the lower state. So that particular condition is going to be added by if then else conditional block. That conditional block is under control category. So from control category, select forever block and if else then block. Attach this block something like this. Now we want to see the ultrasonics echo and trigger pin. Now this trigger and echo pins are there to read the distance. Whenever there is a trigger and echo pins find something at a particular distance, your LED will be turned on. So here one operator block is used. So that operator block is added into this, and after that from ultrasonic sensors option, select a block named ultrasonic sensor pin, trigger pin at on 3 and echo pin on 2, because we have connected the trigger pin onto digital pin number 3 and echo pin onto Arduino's digital pin number 2. Hence we need to read the distance from these two pins. Hence we have added this block here in order to read a particular distance. Now here distance we have added is 10 centimeter. If the distance is greater than 10, then and only then your LED will turn on. If the distance of object is less than 10, then there will be no turning on procedure will happen. So for that we have added this greater than option, and if the whatever distance read by ultrasonic sensor is more than 10, means if the distance is 12 or you can say 13, now this condition is fulfilled, means 13 is greater than 10, the distance read by ultrasonic sensor. For example, it is 13, so 13 is greater than 10, so the condition is true. Condition is true, then it will go for this. Condition is true, then the pin number 13's LED will turn on. If the distance sensed by the ultrasonic sensor is, for example, 6, then 6 is not greater than 10, then the condition is not fulfilling or the condition is false, and the pin will stay in low stage or the pin will be in turn off mode. So this is how you can see the working of ultrasonic sensor. Now the next and the last part of this tutorial is interfacing IR sensor with the Arduino module. So here in this particular session we are going to see that what is IR sensor and its basic working and how one can connect the IR sensor with Arduino Uno and get some data. So first we will see what is IR sensor. So IR sensor here, IR means infrared sensor. So it is something which works on infrared waves. So the IR sensor is an electronic device that emits the light in order to sense some object of surroundings. So whenever you want to sense some object in the surrounding medium, you can use the IR sensor. So IR sensor can measure the heat of a particular object as well as it can detect the motion. So usually in the infrared spectrum, all the objects radiate some form of thermal radiation. Now this type of radiation are visible to our eyes, but infrared sensor can detect this radiation. So the emitter first, here you can see from the module of this IR sensor. So this is the module of IR sensor, a typical IR sensor. It has 3 different pins, it has 2 different LEDs, it has this trim port which is to adjust the distance of threshold. So here this is one module which is IR receiver, the another module which is IR emitter. So the emitter is simply the IR LED or you can say light emitting diode, and the detector is simply IR photodiode. So now photodiode is sensitive to IR light of the same wavelength which is emitted by this IR LED. So this is the sensitive to the IR waves which is going to be emitted by this IR LED. When IR light falls on photodiode, means here on this, the resistance and the output voltage here, output voltage will change in proportion to the magnitude of IR light received. Whatever IR light received will be changed. Here the IR sensor can measure the heat of an object and it can detect the motion as well. Now all the objects radiate some form of thermal energy. Now this type of radiations are invisible to human eye or our eyes. So as this is a passive sensor, it can only measure the infrared radiation. Now very common in electronic industry, and if you have ever tried to design an obstacle avoidance robot or any other proximity detection based system, this particular thing is very common in use. So the module has 3 different pins. First is VCC pin, next is GND pin, and after that is digital output pin. So the working of IR sensor is, this is the first IR sensor. This is 2 different modules. The first which is IR LED and the photodiode which is going to receive the reflected IR light, and this is the IR LED which is going to emit the light, and this is the object. So now these IR sensors basically is, there are different types of transmitter and depending on their wavelengths, output power and response time, an IR sensor is mainly consist of this IR LED and photodiode. So this IR LED will emit the IR waves, and if there is any object it will reflect back, and that reflected IR light will be received by this photodiode. Let us see the applications of IR sensor. So the IR sensor can be used in proximity sensors to detect the object, in line tracking sensors, obstacle avoidance, flame detection, gas monitoring, temperature measurement, and also barcode scanners to make some security systems. And if you want to make line following robot, then you can also use the IR sensors. The next step is to interface the IR sensor with Arduino Uno. So we are connecting now IR sensor with Arduino Uno. So here we will make a basic project where the IR sensor detects an object, and that detection of object is going to be indicated by indicating LED. So here we are going to use one LED to give the indication of detection, and the IR sensor is going to detect or going to sense the data. The project concept is very simple. When an obstacle or object comes in front of IR sensor, then the sensor gives an output to the Arduino. Then the Arduino sent output voltage to turn on the LED. And when the sensor does not detect any obstacle, then the Arduino Uno turns off the LED. So this is how is basically our project going to work. So let us see the hardware required for this particular activity. Arduino Uno, one USB A to B type cable, computer or laptop, jumper wires, IR sensor, one LED and one resistor. So these are the hardware components which we are going to require. And the software which we are going to require is Blockzie software. So this is the circuit diagram, and here we have connected the IR sensor and LED. This is the LED, this is the IR sensor, and this is Arduino Uno board. So here the digital pin or digital output pin of IR sensor is connected onto the digital pin number 2 of the module or Arduino Uno board. The GND pin of IR sensor is connected to the GND pin of Arduino Uno board, and the VCC pin of IR sensor is connected to the 5-volt pin of Arduino Uno board. The LED anode terminal is connected to the digital pin number 13 via a resistor, whereas its cathode is connected to the ground pin of Arduino Uno board. So this is how the IR sensor and LED is going to be connected with Arduino Uno board. Now let us see the coding for this circuit. So first we are going to add the Arduino Uno board. So for that, use the node device selected pin, and clicking on that icon you will have an option to add the Arduino Uno board. After adding Arduino Uno board, we just require to add a few blocks in order to sense that. So first, from event category, select when Arduino Uno begins, drag and drop into coding area. After that is we want to set the these two pins, that which device is performing as which particular type. So for that, here is our IR sensor and here is LED. So LED is connected onto pin number 13 and LED is our output device, whereas the IR sensor is connected onto pin number 2 and that is input device. So set pin number 2 as input and pin number 13 as output. So these are the two blocks using which we have defined that LED is output device and IR sensor is input device. After that, whenever the IR sensor detects something, the LED should turn on. If it does not detect something, the LED should remain in low state. So it will read the digital pin number 2, because onto the pin number 2 we have connected the IR sensor. So using this block, we need one conditional block. So first we will add two blocks from control category, and that are forever blocks and if and else block. So under the forever block, connect this if and else block and take a reporter block of greater than. Now take one read digital pin block and add into the first blank area, and here we need to add the digit. Here we are going to add the digit as 0, means whenever there is something data which is going to be sensed by the IR sensor, because here we have connected IR sensor. So read digital pin number 2 if the pin number 2 reads something greater than 0, then LED onto pin number 13 is high. Means we have added a block which says set digital pin, and that is 13 pin number, and its output should be high. If this condition not satisfy, means there is nothing which is detected by IR sensor, means there is no detection, then your output or the LED will be in off state, means set digital pin 13, which is LED, into low state. So this is how the IR sensors connection with Arduino and block coding works. So this was all about the sensors and actuators and how one can connect different sensors to Arduino Uno board and do the programming in block coding. We will see you in the next tutorial. Thank you so much.